Hello everyone. Yeah, very good morning. So, as you can see on my screen, there is a diagram already and showing there. So, today we have another approach to solve the Fibonacci, and we are going to use the tabulation method this time. Tabulation method is also the dynamic programming part. It's a second approach to solve any problem. So, what we are doing here, we are using the iterative approach and using a table array, okay, to just solve our Fibonacci problem. So as you can see on my screen, I'm going to explain this particular diagram today. uh, yeah, so let's start this on and on this weekend. Okay, so as you particular, you can see on my screen there is a main method. This main method is our particular main class, Java main class method, and this is calling the method of another class that is having that method is named something Fibonacci tabulation, and inside the method we are using a loop that is running from I is equal to 2 to n. Now your question is why it is running, not running from the 0, and why it is running from the 2. Yeah, so as you can see from the main method, we are already storing the initial value inside the array, that is table 0 and table 1. Okay, and other parts also. So let's ignore the table 2, 3, 4 values because this is not going to use. Initially, we will use these values to calculate to find the value of table 2. Okay, so that's what initially we are storing these values 0 1. So already two values already stored, so we are starting for a loop from the I is equal to 2. Okay, so 2 is for second index of the table. So that's what. So second, what is the n here? And we are giving the input n. N is that number which we want to find the Fibonacci series, and which is given by the user. The user is saying, hey, I want to find the Fibonacci last number for this particular n. And is n can be thousands, n can be 50, n can be 70, n can be 100, anything, right? Yeah. So as you can see inside this loop, we are using this computation logic to just from the previous index, we are using the adding some technique, some operation. Okay, adding operation, we are performing the addition, we can say, or so to calculate the next index value. Okay, so what is happening here, and after doing addition, we are storing those values inside the next index. So table 2 value will be updated. So if you see I is equal to 2, so I value is 2, to 2 minus 1 is 1, 2 minus 2 is 0. So table 1 and table 0 value already we have 0 and 1, so 0 plus 1 is 1. Okay, so now 1 is going to store inside the table I, that is 2. So the table 2 value will be updated as a 1. So now this process will continue till the end. Okay, so I hope you guys got it that, and got it this diagram, right? And what approach the diagram are following, this is bottom up approach, because we are just going step by step to the top. So from the bottom, like from starting from the 0 1 2 3 till n. So this is the bottom up approach in the linear manner we are going, right? Okay, so let's now uh, let's go to the coding part. Okay, yeah, so this is our coding part, and here we have the main class, that is Fibonacci tabulation, and this is the main method. So from the main method, we are just creating the object of another class using this new object, and using this object particular reference variable, we are calling that method, and we are passing the parameter our input n, and as well as table array. Table is our particular memory something. So we are passing inside this particular method. as a parameter. So what is happening, as you can see, we already applied the for loop here, and we are already applied this particular expression over here. So what is happening, suppose that I is equal to 2, so it is starting from the 2 and it is going till to the end. So what is happening here, I 2 minus 1 the same thing. 2 minus 1 will be 1 and 2 minus 2 will be 0. So as we can see, we have already the value 1 for 1, it is 1, and already I fill the value for inside the table, that is 0, all the table. So and 0 will be 0. So 1 plus 0 will store inside the 2, table 2, second index. Okay, so it will be 1. And after that, when its all loop will be completed, okay, so this will be written from here. That's it. Okay, so let's debug this program. Okay, so I'll take the small value, don't worry, that particular something 5. Okay, so as you can see, on particular 5, n value is 5 and we have the table. So if you see, the table is 0 and 1 already initialized, other parts are 0 actually. So we are going to predict the value of other parts from this 0 and 1. Okay, so it is the bottom up approach. From the bottom 0 to 5, it is going to predict the value. So let's debug this. Okay, so now if you see, I came inside the loop, the and we are calculating for that I is equal to 2. 2 minus 1 will be 1, 2 minus 2 will be 0. Okay, so already if you see, table values, so the second array value, the second index value will be predicted over here, predicted or stored over here, not the predicted, stored over here, right, in the memory. Yeah, yeah. So if you see, if I go again, so if you see, 2 is 1. 2 is 1 because 0 plus 1 is equal to 1, right? So that's what we are using these memories, is previous stored values, to calculate the next index value. Okay, so now let's see what other approach. Third index values are also updated. Now if you see, like, fourth index value is also updated. This is the same thing happening here. Now for the 5 also, 5 minus 1, 4, 5 minus 2, 3. So if you see, 4 and 3 already we have value. 3 to 5. So next value should be 5. Okay. So if you see, inside the table, next value is 5 on the fifth index. So now we are returning this. Okay, so if you see, 5 is printed here for that. So let's stop this debugger and let's run it simply. Okay, so let's find for the 50. So if you see, 50 last particular number will be returned, number returned, and the time taken in nanosecond actually. Here we are using the nano time, so it is 10 to power minus 9. Okay, so that is the nano time. Yeah, so it is taking 3,13,900 nanoseconds. Okay, so also we can see the complexity of this program. So as you can see, the same approach we are expression we are using here, right? Tn minus 1, Tn minus 2. So here we are using the same approach, Tn minus 1 plus Tn minus 2. But here what we are doing, we already have the table, right, where we are storing the 0 and 1. So for and we are running the using the iterative approach actually. Iterative approach, what is that? This is loop. This loop where here we are using for loop, that is called the iterative approach. Okay, so here we are using the iterative approach, and we are calculating these value like that. So T2 minus 1, T2 minus 2, then T2 minus 1 will be T1, and T2 minus T2 minus 2 is equal to T0. So if you calculate this value from the table, if you see the value, check the value, it will be 1. Okay, for the table second index it will be stored. So like that, same will be happen for loop I is when I is equal to 3. So when so T3 is equal to T2 plus T1, and their value will be something like 2, and here it should be 2, right? Because second index is also having the 1, and first index is also having the 1. So 1 plus 1 is equal to 2. Okay, so like this it will be run for from I is equal to 2 to n. But how we are calculating head complexity? Because we are using the loop iterative approach till the end, from second to till the end. So the running time of this particular time complexity of this approach will be big O n, because we are using the loop 0 to n, sorry 2 to n. Okay, 0 and 1 is printing, that's what. But 0 and 1 doesn't matter because it is constant. So from the 2 it is constant, so we are going towards the n approach. Suppose the n value is very large, like 1 lakhs. So in that case 1 and 0 will be very less and negligible, right? So that's why we are just saying we are using the iterative approach till the n. So the complexity will be big one, time complexity. And yeah, so let's compare this particular approach. uh, let's compare the time of this approach to another to other previous approach. Okay, yeah. So as you can see, for the 50 we got this 313900, perfect. And let's do it, and let's go there in memoization technique and run this for the 15, that is nanosecond also have. So it is 130100, 130 1 lakh 30,100. It is also very less actually, if you see. And it's 3 lakh, it's 1 lakh 30,000. Let's see inside the simple recursion technique for the 15. So it's very high, 5 lakh 31,601. So that's what we considered here best approach. We are using the dynamic programming, so your time will be reduced. Okay, so if you see from using the simple recursion techniques is 5 lakh 31,601 nanoseconds, and if we are going with memoization technique it's a 1 lakh 31,100 milliseconds, and if we are going to tabulation technique it's 3 lakh 13,900. Okay, the time complexity. But here in tabulation technique the space complexity is cool, like the bigger one in tabulation. In particular, in tabulation the space complexity is bigger one, and in memorization actually technique, memorization technique, the space complexity is bigger one. So space will also be better here inside that memory. A memory exception will not be thrown. So guys, out of memory I will exception come up with new interesting I hope topic you all in of next got video it, this program. So and we'll understand together, and we'll find the complexity as well. We'll find the particular approach. We'll also debug together in the next video. Okay, till now, happy weekend. Bye bye.